Watch Claude Code create files, edit the code, run Git commands, install packages, or execute terminal commands as well. It almost feels like the AI has taken control of your computer. But that's not what's actually happening. The language model itself cannot open your terminal or edit your files. Instead, it requests that specific tools be executed by the application around it. This engineering pattern is called tool calling, and it's one of the most important building blocks behind modern AI assistance. Before you even type your first prompt, Claude Code already knows which tools are available. The application provides structured definitions describing each tool, its purpose, and the arguments it accepts. For example, there may be tools like read_file, write_file, execute_terminal, get_status, and search_codebase. Claude isn't discovering these capabilities by itself. The application explicitly tells the model what actions it is allowed to request and the exact structure those requests must follow. Suppose you ask, explain what Kubernetes is. Claude already knows the answer, so no tool is required. But now, imagine you ask, find every to-do comment in my repository. Claude cannot possibly know your local project. It reasons that the answer requires external information and decides to use one or more available tools. Tool calling is therefore a decision. The model first determines whether external information or an action is actually necessary before requesting anything. Now Claude decides to inspect your project. It might generate a structured request asking the application to execute search_codebase with a query to do or EAD_file for a specific file path. The important detail is that Claude has not opened your files itself. It has only generated a machine-readable request describing what it wants the application to do. The application can validate those arguments, reject unsafe requests, or enforce permissions before anything is executed. Now the orchestration layer takes over. It receives the structured tool request and executes the real implementation. If Claude requested execute_terminal, the application launches the terminal process. If it requested read_file, the application reads the file from disk. If it requested get_status, the application runs Git and captures the output. Notice that all of this happens outside the language model. Security, permissions, validation, and execution remain under the application's control. Once the tool finishes, the application sends the result back to Claude. If it executed a terminal command, the output might contain compiler errors or a successful build message. If it searched the code base, it might return a list of matching files. Claude didn't know any of this information beforehand. It now reasons over the returned data, understands what it means, and produces a helpful explanation or decides what action should happen next. It's important to distinguish tool calling from AI agents. A simple interaction may involve only one cycle. Claude requests a tool, the application executes it. The result comes back and Claude answers. That's tool calling. An AI agent extends this idea. It observes the result, decides another action is needed, requests another tool, evaluates the new result, and repeats this process until the goal is complete. Tool calling is therefore a capability. Agents are systems that repeatedly use that capability to achieve complex tasks. Although we've used Claude Code as our example, the same architecture exists across modern AI products. Cursor reads and edits files using tools. ChatGPT can search the web or access external services using tools. GitHub Copilot can invoke development capabilities through tools. The engineering pattern remains exactly the same. The model decides which capability it needs, the application executes it, and the result returns for further reasoning. Let's put everything together. You ask Claude Code to perform a task. The model receives your request together with the available tool definitions. If external information or an action is required, it generates a structured tool request. The application validates that request, executes the real function, and returns the result to the model. Claude then reasons over that information and generates the final response. If you remember one thing from this episode, remember this. Claude Code doesn't directly control your computer. It decides which tool should be used, while the application remains responsible for executing every action. Hope you enjoyed the sketch. We'll see you in the next one.